committee, we've selected him as one of 4 candidates to might be able to receive the fellowship prize of 10K. So welcome, Mohammed. I think
Hello, everyone.
we are good to go now to kick off the session, modeling and simulating decentralized economic systems with the application of AI and machine learning at TE Academy today. Let me briefly show you the program today. Hello, everyone who is participating in the session on Zoom. Great to have you all here. Excited to get to know you. And also welcome to everyone who is joining us on Twitter and YouTube. There's still time, by the way, to register to the study season so that you have full access to the materials. Scan this QR code, register, and you'll be part of the study season and have access to all the materials, can be part of it, can actively participate in the exercises we run together with Mohammed. Cool. Okay, our program today. We'll share some more information about the where, what, and how. So to let you know how you can actively participate, also how you can earn your own proof of knowledge based on successful completion of this program. Additionally, we'll run an introduction round because we'd like to get to know each other. We might work in teams, so it's just good to see who's here. And in the second part, we'll kick off Mohammed's lectures, modeling and simulating decentralized economic systems with the application of AI and machine learning. And we'll have the Discord channel to continue the conversation, to work on homework assignments, etc., to share links and comments. And really, we'd like to encourage you to be active, to be proactive even, spin up your own learning sessions, meet with students before and after the sessions to continue learning. All right. We have 3 components in the study season program. So we have our sync meetings like today in Mohammed's series of lectures. It's always on Thursdays, 8:30 a.m. UTC, same time every Thursday in the next weeks. Then there's this asynchronous discussion on Discord. It's an open schedule. You can work in team. Please feel free to organize yourself. Be reasonable with time. I guess Mohammed is always happy to answer on questions, but of course he might not be available 24/7. Nevertheless, we know that you are all in many different time zones, so it's totally okay to watch the recordings and start pinging your fellow students, share your insights, and have a good conversation on Discord. Finally, there might be homework assignments, or there might be exercises, or you can even pick your own task to dig deeper, to gain hands-on practice, and finally receive your proof of knowledge. Some words on culture and values at TE Academy. We have community guidelines. They are available on our Discord. Please take a look. It's about giving and getting, sharing knowledge. This is a young discipline. Every single person matters and will have an impact. Be fair. It's totally cool if you build on everybody else's knowledge. Just mention them and praise them. Again, to solve issues, reach out to fellow students. Feel free to schedule additional learning sessions. And there are no stupid questions. So whenever you need support, reach out to your fellow students. Be mindful when asking for support. Praise and say thank you to those who supported you, and give back whenever you have the chance. One more word on minting NFTs. So TE Academy has established a system of proofs of knowledge based on non-transferable, non-fungible tokens, the NFTs. And you'll have the chance to acquire your own proof of knowledge for this course at the end of the series of lectures. So this will be end of May to beginning of June, where we'll run an online exam. So you can take this online exam online. You have time. I guess we have to define what's the passing rate. This is still a matter of definitions and design. We are working on this with Muhammad in the background. We'll keep you posted on how this works, how you can access the exam, and when by latest you have to submit your results, and then you will be eligible to mint an NFT. Hold it in your wallet, gain additional power for decision making in the community, like for the decision who should be the winner of the fellowship prize. And of course, in case you'd like to say thank you to Muhammad for running this series of lectures, you should definitely mint your NFTs, any NFTs you can get, to have voting power and say thank you to him via supporting him in the voting, just to let you know. Next slide. Oops, I have to find my tabs. Okay, the Notion Study Season Information Hub is the central point of information. I'll drop the link to this Notion to Discord and also to the chat here. You should have it. We shared it multiple times. It's your central place to find all the information about Muhammad's lecture. So the recording, GitHub maybe, slides, we'll collect everything to make it available to you. So also the Zoom link for the sessions. This is all available in the Study Season Information Hub. Okay, that was it regarding logistics. If you guys have any questions, drop a note to the chat anytime. Just let us know. Good. Time for the introduction round. Muhammad, I'm impressed by your background, I must say, and I'm super excited for your lecture series. Please let us know what's your background and what brought you to token engineering.
Hello, hi everyone. Good morning. It's great to be here and share my knowledge with all the candidates of Token Engineering Academy. So I am working in this token engineering domain from last 2.5 years. So I started in start of 2022. I have an educational background of robotics and machine learning. So after my graduation in 2018, I worked with the automation systems and stuff related to the robotics. But later I shifted towards this blockchain domain. And then I tried to explore different opportunities that how can I apply my knowledge of machine learning, AI, and data analytics in this emerging crypto native discipline of token engineering. So I found it very interesting in terms of that how you have power to build new economies and how much impact you can create with your work. So I started following TE Academy. I completed TE fundamental modules, and there were different resources like Block Science was doing great research work on the in the domain of decentralized autonomous organizations. So I followed them. Then TE Labs and all these organizations were trying to figure out that how to go with this new discipline because it is very new and no one knows that how to start. So I followed them and they led me to this place where I am here to share my knowledge with the other candidates. So it was a great journey, and looking forward to share my journey and all the roadmap which I followed and what I'm doing right now in these upcoming sessions. And thank you, Token Engineering Academy, for giving me this opportunity to share my knowledge. Thank you.
Thank you for being here, Muhammad. I just realized that I didn't even introduce myself. I'm Angela, just in case. I'm the founder of Token Engineering Academy. We started this in 2020, and since then are working on the best educational program we are able to provide to students, all as a public goods, and also opportunities to meet and network and to grow the discipline together, like the ECC Token Engineering track or network meetings live or online. And with me here is also Fabi, who is responsible for all the recordings, distribution of material. She's also on Discord, so whenever you have a question, where can I find something, reach out to Fabi.
This meeting is being recorded.
Hello.
Hello. So I started my journey with blockchain like 3 years ago, just taking some cohort about how blockchain work generally, the ecosystem. And then I discovered token engineering, and I really liked the discipline that it is combining really different fields from philosophy to computer science and every other field around. So I really like that very much. And then I participate also for courses on NFT about hyperset for token engineering. And otherwise, I have also background, technical background in embedded system programming and web development. I did also some smart contract on the blockchain. I participate also to the hackathon, but what is interesting me is really this creation of value from a high level. That means that you are able to design a system to coordinate people to do something meaningful. So that's why I am here, and I am interested for the simulation of the different network based on token. So that's it.
Cool. Thanks for sharing. Welcome. Great to see you again. Marcin, would you like to go next?
Hi. Hi. Yeah, so my name is Marcin. I'm a UX designer for like the past 10 years or so, some project management, I've done some development. In 2017, I got really into Steam, and that was kind of my introduction to these kind of novel mechanisms. I also remember finding the nonprofit casino where all the houses wins are redistributed back to the players. I just thought all this stuff was really amazing. And then after 2017, it just seemed to continue into sound money and TVL and stuff like that. And I just seemed like a very different set of priorities. Had a hard time reconciling them myself. Yeah, but long story short, that's kind of where my interest came from. I had a NFT startup for 2 years.
Mhm.
And now I have another project in mind that's a bit more demanding. And so I'm here.
Well, thanks for joining today.
Yeah.
There's Albena. Would you also like to introduce yourself? Hello.
Hi there. Thank you for everything you're doing. So my name is Albena. I am a crypto market expert for the last 5 or 6 years. I have worked for proof of work layer 1 chain. I have worked for decentralized commodity derivatives exchange. I have worked for blockchain and AI. In my tenure in Web3, I have also gained a bit more technical knowledge in data science, machine learning, and deep learning. And my studies coincided with the launch of ChatGPT. And for the last 6 or 7 months, I am writing a weekly blog and newsletter covering the Web3 and AI space. It's called Web3 AI. I invite you all to check it out. So right now, that's what I'm doing. I'm building my blog, and I'm also on the founding team of ETH Sofia. We are organizing the first conference and hackathon dedicated to Ethereum in Sofia, Bulgaria. It's going to take place in October. Again, everyone here is invited to join. And I'm also trying to really put Web3 and AI under the spotlight on our event. So I'm really interested in discovering new ways to combine these two technologies and to check out how AI and machine learning can be used in token engineering. So thank you very much for organizing all this.
Cool. Albina, make sure to share the links to your blog and to
Sure.
Sophia. Awesome.
Thank you. Sure.
Dimas, would you like to go next?
Hi, everyone. A pleasure to be here. I know Token Engineering Academy since 2 years ago. I discovered this discipline through Shermin's books. That was amazing. Angela, we actually met in Ethereum Barcelona 2 years ago.
Yeah.
And my background is I'm coming from aeronautical engineering. And since I discovered blockchain, I feel like I want to deep explore a little bit about this whole economic or new economic system, how they are designed, and let's see if I can start my career in this discipline. Actually, this track is a bit challenging for me because I'm now starting with Python and everything, but I take like an opportunity to have a deeper view in how model and simulating this system. So I'm excited to start the session.
Thumbs up.
Thank you so
Thanks
much
for the introduction, Dimas. Bryn.
Me?
You, yes. Did I pronounce it correctly?
Yeah, which is rare. Thank you. Yeah, Welsh names are quite difficult. Yeah, so my name is Bryn. I have worked in Web3 for about 3 years now, and I founded a DAO that helps educate people about Web3 privacy. I also do AI classes for beginners in Barcelona as well. And at the moment, I'm working in a Web3 legal and regulatory advisory. So helping people to solve all these issues related to, changing laws around crypto regulations around the world, helping them to form DAOs. And we're actually building some tooling for DAO management as well, with privacy baked in and all these other features. So yeah, happy to connect with anyone that's interested in DAOs and how that's all rolling out.
Okay, thanks, Bryn. Thank you. And let's take a final one. Mate.
Hello. Hi. I'm
Hello.
so glad to be here, and thanks for organizing this. Yeah, I have a background in physics and philosophy, and then I became interested in the philosophy of physics. It's like theoretical questions in physics. And then I started to work as a machine learning engineer. And so I did some medical stuff. It was lung cancer diagnostics. And yeah, I dealt with the data and built models, and that was really fun. But now we are selling a new instrument, a completely new. It's like an acoustic invention. It's called Glissonic, and that's my project right now. And I'm so interested in these technologies, how they coincide, AI and blockchain, and that's why I'm here.
Okay, thanks for the introduction. Before we start the session, I want to go to Discord with you all just to show you around. Let me just find the right track. So I hope you are all members of our Discord now. And we have created channels for all the live track sessions where we already dropped some notes and questions. And I would ask you now to go to our Discord and join channel number 6. This is the channel of this live track. And if you haven't, just indicate who you are by clicking the emoji. Answering on this question as a token engineer or someone interested in token engineering, which challenge do you believe are the most critical in the modeling and simulation of decentralized economic systems? And Muhammad, just suggests a number of answers there. There's also the option you answer yourself with providing an alternative answer. What do you think? What challenges are most critical? Developing a simulation interface for non-programming stakeholders, mathematical definition of complexity, integration of real-time on-chain data in your models, adaptability of models and simulations to sudden market changes and fat tail events, extracting decision-making insights from models and simulations, and translating them into actionable insights and strategies, validating and testing models under diverse scenarios, adoption of models to emergent behaviors, finding a trade-off between complexity and simplicity of models based on desired goals or others. And I definitely see there's no clear answer, obviously, on that one. So I think we'll take up and pick up these questions again throughout the course. And there is no finite answer to this question yet. I think we are good to go, Mohammed. Let's dive in. And thanks everyone for the introduction round.
Sure, I will be sharing my screen. Just give me
Mhm.
and let me know that it is visible. Can you guys see?
Yes, we can see it. Mhm.
Okay. Our slides changing.
Yes, all good.
Okay. Okay, got it. So let's take a look at the roadmap of our track. We have 4 focus sessions ahead of us. So we will be using a top-down approach where we will be starting with the building a theoretical framework that why we need modeling and simulation in decentralized economic systems. And then we will delve deeper into the nuances of that, how to model and simulate different decentralized economic systems, and what are the challenges which are faced by current tools and models, and how we can leverage AI and specifically generative AI to in order to overcome these challenges. So the first session, we will be understanding fundamentals of decentralized economic systems and their modeling and simulation environments. And the second session on the application of AI and ML in token engineering. We will explore how AI and ML technologies are being applied specifically in the field of token engineering to enhance system design and functionalities. So in our third session of advanced AI ML powered modeling and simulation techniques, we will dive deeper into the cutting edge AI and ML techniques that drive innovation in modeling and simulation. We will be exploring intelligent liquidity provisioning framework, which is built using agent-based modeling and then reinforcement learning to optimize liquidity provisioning as a case study, which we will be discussing in our third session to practically see that how machine learning and AI is applied in a project to better simulate and model different decentralized finance and in different domains in blockchain. And in our last session on emerging token engineering research topics at the intersection of blockchain and AI, we will discuss latest research and current trends at the intersection of these two technologies, and what is the role of token engineers in developing new use cases at this intersection. So let's start with our first session. modeling and simulating decentralized economic system. So we will start with the very high level of abstraction, and then we will try to build an argument that why we need modeling and simulation in decentralized systems. Can you guys see these slides? It's currently slide of objectives. Can you guys see this?
I see the session overview, 1, 2, 3, 4.
Session overview, you can't see the next slide of objectives.
No. Now. Now we have the objectives.
Okay, so in this session, we will aim to achieve certain key objectives that will enhance our understanding of decentralized economic systems. And here's what we plan to cover. So we will explore the dynamics of decentralized economic system, that how contrast they are with the centralized system and what unique dynamics they present. And then we will be exploring that what are decentralized economic systems, what are the properties of decentralized systems that are different from the centralized settings, that why we need this token engineering domain actually to build an argument that what is the role of token engineers in product life cycle of this decentralized system. So then we will discuss importance of modeling and simulation, and how we can leverage modeling and simulation to make these systems sustainable and robust in different kind of environments and scenarios. So and also we will be discussing current token engineering tools like CAD, ABM from very high level, that what these tools are and how they are being used in this domain. And finally, we will discuss the challenges faced by token engineers in using these tools, and how AI and ML can solve these challenges by applying these techniques of machine learning and AI. And now we are at the next slide, which is on what constitutes an economy. Angela, is it visible? I just want to reconfirm that don't have to.
Yes, we can see it.
Okay. Okay, so let's start with the very basic concept of what is an economy, what are the different components which make an economy. So understanding these elements is essential in a sense that for anyone involved in modeling and simulation. So we will be exploring that what are the different components of economy. And the first one is resources. So these are the inputs needed for the production of goods and services. And production is actually the process of combining different resources to produce goods or services. And the next thing is distribution of these resources to the users and different components of supply chain. And then there is consumption, how these things are being consumed by the end users. In economy, we have a very important component of different exchange mechanism, that how you exchange different services, goods and products, and what is the primary market and what is the secondary market, and how it is designed and who designs it. So that is very important, because it directly reflects our basic understanding of decentralized economic system design. So that is something very which will dive deeper later in this session. And our centralized economic system has a financial system which comprises of banks, markets, and flow. It facilitates the flow of money and credits and different kind of financial services. And then there are economic agents, which are basically the businesses and users who consume these services or provide these services or regulate these services. So these are the major agents of an economy from a high level. And these agents perform some activities which are related to the production, distribution, and consumption of goods and services. So the final element, which is a major component of an economy, is social and cultural factors, as they influence economic behaviors, decisions, and how economic activity will be carried out. So what are the features of conventional economic systems? So here we will explore some of the basic features which uh, as a centralized conventional economic system has. So primarily these systems are centralized, so there are a lot of centralized entities or institutions involved in this. So centralized decision making, all the decision making is done by the regulators or institutions and the governments. So they are responsible for all the policy making and the stuff related to the decision making. So all the policies are built by these centralized institutions, and these are the people who try to enforce those policies on users. So monetary policy is issued by or designed by central banks, so that monetary policy actually acts as levers of economy through which these centralized entities control economies. So what are these levers? They are interest rates, they are supply, demand dynamics, and then these are regulations. Through these levers, these centralized entities and institutions, they control the outcomes of an economy, try to achieve desired objectives. And the fiscal policy, it is again issued by the central banks and central entities. And banking system or conventional banking systems consist of a central bank which actually regulates all the underlying banks, and in some way which looks like a free market, it isn't, because all the policies are issued by the central bank. So all the hard work on the policy making side, that is done by these central banks. And economic planning, that is something which is related to the over this discussion, which may be on modeling and simulation, that in conventional system this is done by the uh, governments and institutions. So they model these economies, they try to uh, figure out different outcomes of this policy, and they try to analyze that how this policy will impact their economic environment, and all the financial decisions are made by based on this planning. So the one of the limitation of this centralized economic system is that market forces are often restricted by government actions. So governments control these market forces, and they control all these dynamics of system. And resource allocation is also done by the centralized entities, so they are responsible for allocating resources and allocating resources to the users and to their economic agents. So now we will jump into the decentralized economic systems, that how decentralized economic systems are different from the centralized counterpart, and what are the some features which constitute a decentralized economic system. So first, the most important thing, that is it leverages decentralized infrastructure of blockchain and distributed ledger technology to provide transparency and immutability of transactions. So that is one of the salient feature of a decentralized economic system and how it operates. And decision making and governance are made collectively by the network rather than central authority. And all the assets and utilities, they are tokenized, and their proof is available on blockchain or infrastructure which we are using, so which enables more easier and flexible transactions. And our decentralized economies, they are autonomous and anonymous in nature, so you don't really have to guide each and every action, because these actions are automated by smart contracts, are different kind of rules which are based on the blockchain, which are immutable, and they are achieved through the consensus mechanism, which is at the core of decentralized distributed ledger technology. And there is a peer-to-peer network structure in our decentralized system, so there are no centralized intermediaries, and transaction occur directly between peers without the need of any centralized entity. So that is one of the feature of this decentralized economic system, and they are self-executing and trustless, because transactions are governed by the smart contracts, and they automatically execute these transactions based on the rules which are defined in the code. So no individual has control over execution of these contracts, and no one can commit anything which is outside the limits of those defined rules. So in decentralized systems, an incentive structure is used for alignment of user behaviors. So you don't have control levers, like you don't have on any hard power or any kind of physical exertion through which you can actually control the system. So these incentives are designed to align the behaviors of users in order to achieve your desired goals. And there are no economic models without traditional management, and economic models they operate without any hierarchical management and structures which are found in traditional economies. So this is the basic difference between what makes a centralized economic system and a decentralized economic system, and how dynamics of centralized economic systems change from the decentralized counterpart. As it's crucial to understand that how they how they are different from the centralized counterpart, so that we can realize that how we can handle them, and how we can build them, how we can design them. To understand that, we need to find out that what has changed in decentralized economic system, which wasn't there in centralized entities. So in control over production, distribution, and pricing. So unlike in centralized systems, where these aspects are often controlled by large corporations or regulatory bodies, in decentralized systems, these are managed by collective decisions of network participants or encoded algorithms. And the economic model and incentives, they are for the control institutions and governments. In traditional model institutions, they design economic model based on the assumption of rational actors and often exert control through regulations. In decentralized system, these roles diminish as the smart contracts and immutable algorithms take precedence. So economic models and incentives are in traditional systems, they are designed by institutions and manipulated by authorities. So they regulate the market behaviors by controlling these models and incentives. In contrast, decentralized systems use tokens and cryptocurrencies to create incentives that are programmed into smart contracts, aiming to encourage desired behaviors autonomously. So policy making and implementation in centralized systems, it is done by institutions, regulators, and governments and corporations through their regulatory frameworks. So these large institutions, they actually control all the policy making and implementation, while in decentralized system, policies are implemented through native currency dynamics and by designing principles of game theoretic and mechanism design to automatically enforce and encourage desired behaviors without any centralized controls. So these difference in dynamics, how centralized systems used to operate and how the dynamics shifted to decentralized systems have actually necessitate the need of this new domain of token engineering, where we have the control of designing of our economy, and we have the control to allow users to act be rationally without any central control or authority. So the role of token engineers is that why crucial in designing these new decentralized economic primitives to in order to ensure that they are robust and they are sustainable for the longer term, so that they can actually produce the value which they are built and are intended to. So next question, which is actually all the background of centralized and decentralized systems, is basically to build an argument that why we need modeling and simulation in decentralized systems. So as we previously discussed, that how decentralized systems have this capability of building new economic primitives due to this nature of decentralization. We have this ability to build new use cases which were not possible in our traditional systems, and we have that capability to enforce certain social behaviors which wasn't possible in traditional systems. So modeling and simulations become a very critical part here, because they are these modeling and simulations will actually let us know that how robust or sustainable these systems are before deploying them. Because once we have deployed a system, we don't have any control over it. So if the users don't behave in a way that we want them to, then they can exploit the system, and these systems can be exploited by users, just like Terra Luna, and there are many other hacks which are related to the economic attacks. So users will exploit if these systems are not built with robustness and considering the dynamics that how to build a sustainable system. So predicting and understanding economic mechanism before building an economic mechanism, it is vital to predict and understand their potential impacts. So modeling and simulation allow us to refine these mechanisms, ensure that and to refine these mechanisms, ensuring that they work as intended in the real world. And handling direct and complex interactions. In decentralized systems, interactions occur directly between participants. It's a peer-to-peer network, so people interact with each other without any centralized authority to buffer these dynamics. So that was the leverage in centralized system, that there are centralized authorities which can dampen these interactions. But in these decentralized systems, we don't have any such mechanism, because these individuals they interact with each other directly without any centralized interference. So this can lead to complex and unpredictable outcomes that require advanced modeling to manage. And emergent behaviors and predicting them and catering them in your design, that is another important thing, because the behavior of participants in decentralized systems, they can change over the time, and they are difficult to predict without any simulation. We cannot analyze those emergent behaviors. So these complex simulations are necessary to foresee these behaviors and adjust strategies accordingly in your token design and in your ecosystem design. And the next point is consensus and change implementation, which is basically the centralized system change in decentralized system require consensus can be challenging to implement once the system is operational. So modeling helps to anticipate and plan for these challenges beforehand without actually deploying the system and being exploited by the users. So these modeling techniques actually enable us to anticipate before these events happen. And designing incentives is very complex process, because you want to incentivize desired behaviors and disincentivize undesired behaviors. And modeling is used to actually design these incentives that align user behaviors to achieve desired outcomes without any direct control. So this is particularly important in systems where there are no traditional regulatory mechanisms are present. So we have to simulate these interactions in order to predict these different behaviors, and then design or incentives which cater all these behaviors to achieve the desired outcomes. So this is the basic argument behind why modeling and simulations are required in decentralized economic models, which weren't that important at our level in centralized systems, because all these stuff was either open loop system where users try to adapt to different situations, and they try to exploit these systems, and then centralized authorities, they come into play and they regulate all these events through their regulations and frameworks of policies where they can handle these kind of behaviors. So in decentralized systems, we don't have that power to actually implement those kind of frameworks. So we do it through designing incentives and through aligning user behaviors by designing incentives which are intended to achieve the desired goals.
Okay,
So,
Mohammed, I don't know if we have time for questions or comments. I would encourage everybody to drop comments or questions to the chat. And whenever you think we can pause for a moment and take a look at the chat, let us know, Mohammed. Okay?
Sure. We can take questions right here in the chat.
Okay.
And we also have a section at the end of our session where we will be taking all the questions. So no problem if you want to take it, we can handle. Anyone has any questions, so just post in the chat so that I can answer them on the go.
Good.
Okay, so the next part here is modeling techniques which are used, different modeling techniques which are used to simulate these decentralized systems. So first of all, to understand the complex interaction between users, agent-based modeling is one of the technique which is used. These models simulate the action and interactions of the autonomous agents, which can be represented by individuals or collective entities, and then we assess their effects on the system as a whole. So in agent-based modeling, we have policy function, which are rules based on the historic data of the individual agents, which we extrapolate to actually assess their effects and emergent behaviors. Through analytical approach, we cannot predict these emergent behaviors, so we use the agent-based model to predict outcomes of a system based on the approach of agent-based modeling. So system dynamics is another approach which is used in modeling these systems. So it is focused on stocks, flows, and feedback loops to understand the non-linearity of behaviors, which helps us to identify oscillations, delays, and bottlenecks critical to the system. So this method is actually used to predict the nonlinear behavior of complex systems, and it is basically approach which is used by CAD and RAD-CAD. These tools are used to are built with this approach of system dynamics. So to refine and test these systems, we use a digital twin, which is a virtual model of the process or our service, which we are trying to build. And then this pairing of virtual and physical worlds allows for analysis of data and monitoring of system to head off problems before they occur. So we virtually deploy this system. We have virtual agents and all the activities which are performed by these our own design agents. We use them to tune or parameters of our model, or to perform different kind of policy decision, which we later will be implementing in the real world. So scenario analysis is another technique which is used for testing and refining mechanisms. So this technique involves creating a detailed scenario to explore possible future outcomes, which can help in strategic planning and decision making. And theoretic design, which applies the principle of game theory to predict the outcomes of interaction between decision makers, to ensure that economic incentives are aligned with the desired behaviors. And incentive structures, they are very critical in decentralized systems, because this technique involves designing the economic incentives that motivate participants to behave in ways that lead to the desired outcomes. And there are techniques to model in order to mitigate scenarios for malicious actors. So it is critical to model that these scenarios in which malicious actors might try to game the system, ensuring that all mechanisms are robust, or there are levers which are in place to prevent such activities. So these are the high level modeling techniques which we use using different tools of token engineering. So now we will come to this part, that how the context which we build around the decentralized systems by comparing them with the decentralized counterparts, and then why modeling and simulation are important. And now we will try to relate that with the token engineering life cycle, that how these processes are implemented actually in a project by a token engineer or by a system designer through the this engineering domain, which actually tries to do all this with the very engineering mindset and with the mindset of building these systems. So we can see this token engineering flower. We have seen it many times before. So the specific aspect of this flower, which we'll be discussing here, will be AI optimization and control theory, and somewhere into the industrial and systems engineering. And we will be specifically diving into the model-based system engineering domain, where we have tools already being used by our traditional engineering domains to actually design systems and to verify them and to optimize them. So how token engineering plays a role in defining our system. So do we have any question up till now? Because we will be now going into the nuances of domain, and anyone
Perfect.
has a question?
And I checked the chat. We don't have any questions there, but in case you have a question, switch on your mic. This is your chance before we dig into model-based systems engineering. No questions at this point?
Yeah, sure. So I think we should go ahead with the token engineering process and how these tools will be implemented by the in the token engineering process. So that is the fun part, where we will start exploring this domain and see that how our approach of modeling and simulation is integrated within the token engineering process. So how we define this token engineering process is design, verification, and optimization of token-based economic system. and the everyone tries to define it in their own way, but this is a very comprehensive definition, which I think is is something which covers all the phenomena which are being addressed by this domain. So the design phase has two major components. It includes token design and then ecosystems design. So while designing a new token, what are the some of the basic questions which we ask as a token engineer? Or what is the utility of token? What are the supply dynamics? What will be the total supply? What will be the initial circulating supply? And if whether it is fixed or it is deflationary or inflationary. So we have to define these parameters of inflation rate, emissions, or if it is deflationary, we have to define the burn rate. And the next thing we deal with that how these tokens will be allocated to different stakeholders, and what will be the vesting schedule of these tokens, what what will be the impact of different token allocations and different vesting periods on the overall economy of our ecosystem which we are trying to design. And these are the some of the questions which we ask in token design phase, which don't have any definitive answer or any answer which fits to all. Every token ecosystem has its own ins and outs, and these questions have their own answers in every different ecosystem. So you cannot fit one model to every token. You cannot have the same dynamics of allocation and vesting as other project has, and it is successful. So you have to build these dynamics according to your own use case and based on your own product or ecosystem which you are designing. And there are different distribution models which are being used to distribute these tokens between users and individuals. There are airdrops. People used to have ICOs. Now there are IDOs. There are private and public sales. There are lock drops which people use to distribute tokens to individuals. And there are incentives. You may distribute your tokens through liquidity mining incentives or any other incentive without conducting any airdrop or any other traditional method. So these are different distribution mechanisms which are used to distribute tokens between users. And pricing of tokens, that is something that we need to figure out before actually deploying a token, that what will be the initial price of token, what will be the market cap while we launch it, what is the FDV market cap which we want to achieve. And these all dynamics are related to a token design which we try to figure out before launching a token. And liquidity and exchange mechanism, that how these tokens will be available on different exchanges, what are the different strategies of providing liquidity, and how it makes makes the process of making this token available to a wider audience more efficient. So these are strategies are related to the liquidity provisioning and making designing a primary market of our token. And there are different dynamics of main mechanism. One mechanism, token sinks, which we employ during our token design. So what is the other thing which we design in this first phase of designing any token economy is the ecosystem design, which is basically design incentive and disincentive mechanism using the principle from mechanism design, and designing these mechanisms which prevent your system from doing anything which you don't want. So these all are managed by this incentive and disincentive mechanism. Then we define different economic agents will be part of our ecosystem, and we try to define them formally with some mathematical specifications of each type of agent, or each entity which is part of our environment, and then we define what economic activities these agents can perform that we want them to perform, and what are the constraints or objectives which we want to achieve through this ecosystem design. So some of the mechanisms which usually the ecosystem design totally depends on the type of service or product which you want to build. So if you are designing a L1 blockchain, the ecosystem will include validators and miners and the stuff related to the transaction fee, and all those parameters will be a part of this ecosystem design. And other type of projects have their own dynamics. So these mechanisms totally depend on the type of ecosystem which we are designing. So staking, liquidity mining, incentive fee structures are few things which are part of most of the DeFi products. So these are some common mechanisms, but there are many which are specific to that token we want to ecosystem we want to build. Samuel, no, you haven't missed a lot. You can join here, and we can, and I will provide the slides and this material in Discord, so you can cope up with everything which we have discussed yet. Okay, so once we are done with this token design phase, the next phase is verification of our design. So what are the different components which are part of this verification phase of our token design? We define mathematical specifications and mechanisms which we designed in the previous phase. We try to formally define them, and formalizing these mechanisms through mathematical model. This will help us to precisely understand and test how these mechanisms are expected to behave. And then we define differential specifications. Our differential equations are used to model the rates of change within the system, and such as how quickly tokens are minted, burned, and traded. So these kind of dynamics are defined through the differential equations or differential specifications of the system. And state space representations are used to define all possible states of the system and transition between these states. It's a comprehensive way to visualize and analyze the dynamics of our system. So we use model and simulation, which we discussed, that different modeling techniques about ABM, system dynamics, and these techniques are used here to actually verify all these mechanisms which we defined in previous phase through their mathematical specifications and their differential equations and all these state space representation. They are verified through models which incorporate Monte Carlo simulations and A/B testing, and there are many other techniques which are used to verify all these mechanisms. Digital twin, again, we discussed it earlier, that it is used to create a digital twin of ecosystem, allows us to monitor the system in real time and simulate changes before implementing them in the actual system. This can be very invaluable for ongoing system maintenance and updates. So once we are done with the verification process, we go to this optimization phase, which in token engineering is where continually refine and improve token system based on real data and performance. This phase is critical for adapting to changes that maximize the system's efficiency and effectiveness. There are some steps to optimize the system, or actually try implement all these optimization techniques. So first of all, we analyze real-time data and feedback to continuously monitor system performance and gathering feedback for users and market condition. So this data is crucial for informed decision making. Projects often have their dashboards like drone analytics and other dashboards on which broadcast this data to public so that they can analyze themselves, and that so that they can make their decision based on the data. So this is critical for users of that platform and also for the product owners to make decision with the help of feedback and real-time data. So based on this data which we just analyzed, we formulate the problem, we define that what needs to be optimized. So this could be increasing transaction speeds, or maybe reducing costs, or improving token liquidity, or any other factors. So we formulate the problem, and then we define objectives and constraints. So we set clear objectives for what the optimization should achieve, and while also considering that constraint might affect this goal, such as regulatory or technical limitations. So these constraints after defining these objectives and constraints, we define the optimization problem. So typically this involves setting up the problem to either maximize returns, like profit or efficiency or any other thing, or to minimize the losses which are being caused by different actors. So we define our optimization problem, and once we have defined that, then real-time data and feedback is incorporated in models and simulations. So models and simulations reflect current data and feedback, ensuring that they remain relevant and accurate. So once we have this real-time data inside our simulations and modeling, and then we perform the parameter optimization for more informed assumptions, because the assumptions which we made earlier in the verification phase, they were very naive because we don't have any real-time data. So once we have some data from the market, then we can make those assumptions more concrete and more accurate through the insights from this data. So we then once we have incorporated this data and optimized the parameters with more informed assumptions, then we can have the ability to swiftly adjust to market dynamics, which is what we can say a benefit of decentralized system. We can remain competitive and responsive even once we have done with the initial phases. Then we can also optimize by optimizing different parameters. Like on Uniswap, we can adjust fees of our pool in order to make an adjustment in our model or any other thing which we want to do. So I am theoretically explaining all these phases of design, verification, and optimization here. But once we will done with this theoretical explanation, in next sessions we will have hands-on activities which will be around modeling and simulation, and our case study of liquidity provisioning framework. It has all the components of different phases, that how it progresses through this process of any product or protocol, and what are the exact steps which we take out here. So we are now done with this explaining that how token engineering incorporates these modeling and simulation techniques in different phases of its process. So now we can discuss tools which are being used currently in this domain. So CAD, most of the people here must have used CAD. It's a system dynamics modeling tool, and it is used for to provide a versatile environment for simulating complex systems and testing various scenarios, making it very easy to use for designing decentralized systems. So CAD has these state update functions, it has policy functions, and it has parameter sweep feature, which you can use to define different mechanisms which we discussed earlier, and then you can simulate them against multiple runs by sweeping parameters of your model, and then finding the right choice of parameters through this simulation tool. So RADCAD, which is another tool which is basically extend the capability of CAD for modeling and simulation, and it's useful for those who are familiar with the Python architecture and who know that this who are more familiar with object-oriented programming. They are more uh, uh, lenient towards this RADCAD because it has more user-friendly interface than CAD. And Token Spice is another tool which is used for agent-based modeling. So our case study employs specifically this tool, Token Spice, to simulate agent behaviors of Uniswap environment. So Token Spice has these definitions of agents, different type of agents in your ecosystem, and then it provides you an interface to model the interactions of these systems with the that how their behaviors will emerge over the system and what these individual agents behavior how they will impact the overall dynamics of our system. So the quantitative token model, which is Excel based tool, it is used to design basics of token like token supply, vesting, and you can model and actually simulate the impacts of different parameters in your quantitative token model. So you can try different kind of utilities and utility allocations through its different modules, and try out different fundraising modules to identify that how the token will evolve over the time. And it has very rich it is actually very useful if you are not familiar with the Python programming or anything. You have this is Excel based model, so everyone can use it. So another tool which is used in this domain for game economy design and simulations is Mechanicians. So it is a very powerful tool for game economy design specifically, but we can use it to simulate other kind of ecosystems also. So it has this user-friendly interface of designing systems and designing their interactions with just pick and drop features and diagrams which you can actually visualize without performing any coding or that kind of stuff. So these are the existing tools which are being used for modeling and simulating different kind of ecosystems in token engineering currently. And the tools, what there are some limitations which are these tools, which are related to these tools. So these limitations are are exaggerated to an extent that no one really wants to use them. So the question which I posted in Discord, that was a question which was on these lines, and Angela actually cracked the question because she reacted on every emoji there. So that is, I think, the correct answer, because all those problems which were there, challenges which were listed there, they are actually present, all of them, in every tool. So that's why their adoption hasn't achieved that milestones. those milestones which we were trying to achieve. So some of the problems are related to the complexity of operating these tools and their comprehending the outcomes of these tools to actually get insights for users. So uh, economic models are simulated with these tools, but they don't provide any actionable insights due to their difficulty to operate and evolve over the time. And then there is this is something which we as a in token engineering domain, which is really being worked on, and people are trying to build new tools which provide better interface to users. So most of the these models, they are deterministic models which assume a set of fixed inputs, or maybe you can sweep the parameters, but still these behaviors are deterministic and they lead to predictable outcomes. So economic systems aren't that simple. They often involve uncertainty and randomness, and making probabilistic models more realistic. But building these probabilistic models is very difficult. So mathematically definition of all different mechanisms and all different ins and outs of the system, it's not that easy, and you cannot apply one model to all. So there cannot be a universal framework of doing this. So you have to design every time it from scratch, which isn't that user friendly for anyone who want to design a new ecosystem or token. So the emergent behaviors, decentralized ecosystems, they have behaviors that emerge from the interactions of multiple agents. So they are not predictable from the initial conditions alone. So capturing these dynamics can be challenging, as it requires simulations that can adapt over and evolve over time, which isn't really possible with these Monte Carlo simulations, and even with the random forest model, because they don't capture the dynamics which are real, because they are random and don't have any real-time feedback incorporated in them. So the last point, which is I think the most important one, is one of the limitation due to which these models aren't being used by most of the products in this domain, is that assumptions which we use to model system, they can be overly simplistic and they can be very naive. So that can lead models to do not accurately reflect the real world complexities, resulting in flawed predictions and strategies. So these assumptions uh, aren't anywhere near to what that system will see in real world. So these simulations, no matter how complex they are, or how uh, random they are, they still them useless, because they don't have any kind of real data feedback. So these are exactly the same those challenges which we discussed in the Discord. So what is the solution of all these challenges which we are facing in this domain? So here comes the uh, actual topic of this track, which we will be discussing. And whole this session was to basically to build up to this place, that where we find out that how decentralized economic systems behave, why we need to model and simulate, why token engineering is relevant to the development of a Web3 product, and why we need AI and machine learning to make these models and simulations more robust, more user friendly, and more informative, so that they can be adapted to every system design and every kind of system. So we have some comments in the chat. So there's a question related to the CAD or RAD-CAD. So I think Angela has answered them already. I think depending on what you want to focus on in general. Angela, do we have any specific question? Because there are a lot.
As far as I can see, I mean, we have some conversations on the chat at the moment. Okay, how many tools, what tools do you have to be able to master as a token engineer? And I think the answer is it depends what you specialize in. And also there is no, I mean, cat, red cat, machinations, they all have their special strengths and weaknesses. And sometimes, I mean, I know many token engineers who have built their own testing suite for their, or simulation suite for their particular challenge, using even different solutions and languages. And that's why I think today it's just hard to say, learn this, and then you'll be able to cover everything. But on the other hand, my recommendation to students would be, don't hesitate to choose any of them. So at the voting track 4, we are using very simple Python models that are really easy to get going and get your hands dirty with running simulations. And of course, if you have the right background, start exploring the ways to model token economies. There are many approaches, and that's also part of, I would say, what makes token engineering so interesting, because it's not finally defined, and there's room for exploration and coming up with new solutions, pretty much project by project, again and again.
Exactly, I totally agree with that. And there is another, I think, misconception in this domain, that you have to specialize everything and you have to do everything. But what I have experienced while working with the multiple products in past couple of years, and working in a service-based company, and currently working with the product-based company, which is working at intersection of blockchain, AI, and interactive NFTs and AI agents, and all that stuff, that you don't have actually have to specialize everything. You just have to pick one specific domain and then build your knowledge around that domain, and then try to use these tools by making them compatible with that domain. So if you are working on supply side token dynamics, so you don't have to really have to learn on all the tools which are not relevant. If you know QTM good enough, so maybe you can work on that and maybe build on QTM, because QTM is very basic, so there are a lot of possibilities to build on top of that. So supply chain tokenomics is pretty much covered by the QTM part. So there are some very basic questions which, once I interact with the different products, when they want to switch from the Web 2 to Web 3, and they want to develop their product in the Web 3 domain, which is already established in Web 2 domain. So they want answers of very simple questions, like what should be the supply of my token, and what should be the initial market cap I have to launch my token, and if it's a meme coin, that then what should be the initial price of my token, how should I distribute my token between individuals and users. So these are very basic questions which up till now are being dealt without any formal mechanism. So if you want to specialize in that part, that is a complete domain which has a lot of nuances. So you don't have to really go into the mechanism design and those parts. If you have expertise in that field, that can be really helpful for a lot of products. So this thing which I realized, that most of people in token engineering, they try to specialize everything, which I already tried, but it never worked for me, because you have to specify your niche, and you have to specify that which specific domain you want to work on, because this is so much. There is a lot of things which are related to the human behavior, and microeconomics and macroeconomics and finance, and you can't learn everything. So I suggest all those people who want to come into this field is to specify into one area. So we were discussing that how to use machine learning and how machine learning and AI is answer to all our limitation, which we discussed earlier, that techniques like reinforcement learning, it can analyze and predict complex patterns and behaviors from large data sets. So these tools can model scenarios that are not intuitively obvious, and they can help in understanding emergent phenomena in decentralized systems. So like in my case study, I have used reinforcement learning to actually build strategies for liquidity provisioning, which is being done by a lot of different analytical approaches. But reinforcement learning has that capability to actually learn from the data and then make decisions independently without overfitting to data. So it has this capability of adapting to the environment. So this is the one of the use case which I worked on at the intersection of this domain, and there are many others which can be built. So if you are using this framework of reinforcement learning, you don't have to explicitly design all the mathematical definitions of all the actors, because you have their data. You have the data of trading agents on Uniswap, you have the data of liquidity provisioning agents on Uniswap, you have data of MEVs and all other agents which you want to model. So you don't have to explicitly define the policy of each individual agent. You can just use this machine learning model, which are very efficient in handling large dimensional data. So they can perform all these activities, and they can learn all these patterns without much of human input. So they can you can train a model and then evaluate it, and if it is working, then you can deploy without providing it continuously with your inputs, because once the new data will be used to train the agent, it will adapt to the behaviors and environment based on data. So behavior models powered by AI can analyze past user behaviors to predict future action. And these techniques from the field of behavioral economics can be integrated with the machine learning to refine these predictions. So making them more accurate and reflective of real human behavior, like trader LP policies in Uniswap. So that's how machine learning can really help users in modeling and simulation. One of the pain point is related to the mathematical definition and defining specific differential specifications of each mechanism. So if you have leverage this AI, you don't have to model individual behaviors. So this is one of the aspects which we will be discussing in detail in next session, that how reinforcement learning is applied on Uniswap and how we can extend it to the other platforms and other domains and to other use cases. Another aspect of seeing this AI and ML is something related to the first point in our question, which was building a user interface which is friendly for non-programming stakeholders. So there was initiative from the Token Engineering Academy regarding CAD GPT. So I took inspiration from that and I built Token GPT, which is custom chat GPT model, which basically performs different simulations and different kind of data analytics based on text-based interface. So it has retrieval augmented generation implemented. So it has knowledge base of token engineering, and I have compiled all that knowledge which wasn't and annotated them with the specific tools and that to in order to make it clear for the chat GPT for retrieval. So I tried this token GPT, and it is much more efficient than your normal chat GPT because it has domain knowledge, and this custom GPT is also available on token GPT plugin. So I will share the link in Discord and you can try it, that how efficient is that in ordering to questions related to token engineering. So I'm also working on extending it to make it compatible with all the simulations and models which we are currently using. So by using function calling capabilities of these generative AI models, so then we can automate modeling and simulation part, even the definition of formal definition of different mechanisms. We can use it without much knowledge of programming and coding, and we don't need to have a lot of knowledge of maths in order to do it, because we can use chat GPT, we can interact with it, and we can uh, uh, extract all these definitions leveraging this generative AI, and then also perform simulations. And it has also access to the different data APIs like Dune Analytics. It has access to the Uniswap subgraphs, to DeFi Llama, and all APIs which are available for on-chain data. So it has access to live data to incorporate that in our simulations, and even to the simplest to answer the simplest questions. So that is something which is partially built. So I will also give you a demo of that, how it's working. And then we can also see that how we can extend this to actually address this limitation of not having a user-friendly face for user-friendly interface for non-programming stakeholders. So that is something which can solve that problem. So I will try to address all these problems which are related to this token engineering domain, that how we can leverage AI and machine learning to solve these problems in our next sessions. So I think the AI ML solutions can really enhance this complete token engineering domain. And there are a few points which I have mentioned here, like handling complex dynamics and emergent behaviors. So AI can help develop more intuitive user-friendly interface using generative AI, and complexity using high dimensional data, which is very difficult to interpret through analytical models. We can leverage machine learning algorithms to handle this high complexity data, and then use it to get insights. And another problem is real-time data integration, because if you are using a model or simulation, then you have to change almost everything if to incorporate the new data. So AI handle that new data without any change in your model. So it can provide you real-time insights without much work you have to do and iterate. So once you build a model, it will automatically get new data and try to use it for making predictions and to help you in decision making. These models are robust to the market changes and fatal events, so they can be can be used to detect different patterns indicating market shifts or upcoming events. So these models are used in decentralized finance and in traditional systems, so we can leverage them here in this token engineering domain to conduct these kind of feasibility and risk assessments. So
Muhammad,
these
sorry, I don't want to interrupt. We just have a pretty interesting question in the chat. Just wanted to highlight, but continue.
Yeah, I think yeah, I just wanted to go towards the question answer session now, because I think it's been 1 hour and 21 minutes, so it's pretty much the time. So we don't have a lot of time. So I just want to finish it with the final giving an overview that in next sessions we will be doing all that stuff by building on this basics idea of why AI and machine learning is required in token engineering domain, and we will be conducting hands-on we will be doing hands-on implementation, and we will be going deep into the implementation of this ILP framework and token GPT. So that's it from this session, and you can go ahead with the question answers.
Yeah, Woo Sung, you dropped a pretty interesting question on agents fitted using machine learning. So I think you raised a very good concern. Do you want to switch on your mic?
Sure thing. Thanks. I'll also switch on my camera to say hi. Yeah, thanks, Mohammed. Really been enjoying the talk, and yeah, everything's great. So yeah, a bit of context. I have actually worked a bit with CAD and RADCAD, and have built agents in the past to model some complex scenarios, or to kind of cover a whole range of possible scenarios to kind of optimize the system. And the one question that I've always pondered with myself was, given the data set that I've used to train my agent, either by using reinforcement learning or inverse reinforcement learning, what is the best way to validate the accuracy or the credibility of the behaviors of these agents? Because how I understand it is, and you can correct me if I'm a bit misled or wrong, but the outcome that we observe in reality is just a manifestation of a single possible outcome of a whole range of possible outcomes, right? So then using that data to fit these agents is almost conditional fitting. We are fitting the agents to kind of create an outcome that could have been just as likely as any other 1,000 different outcomes. So then when it comes to actually producing a reliable range of scenarios to test my model under, can I rely on these set of agents which have been trained on this conditional set of data? And then what would be the best way to validate its credibility? I don't know if that question makes sense.
Yeah, it totally makes sense. That's very good question, because when we dive into the world of machine learning and specifically reinforcement learning, so you always face this question that what model is a good model, and how you how to find out that whether these behaviors which we are trying to model, how realistic are those. So one of the techniques which we use is comparing it with the baseline performance. So let's say you are using any tool to model the behavior of a Uniswap trader agent. So you have modeled that behavior, and you started getting outcomes from this agent by running it, and then you have some baseline strategy already implemented, which could be based on a deterministic model, or it could be based on the real data. So you compare your agent, which is a predictive, outperforming that baseline strategy. It means that it is doing good. So like in ILP framework, I have used different kind of baseline strategies to evaluate the outcomes of my agent. So one of those strategies are deterministic strategies, like using strategy of a different liquidity manager, and then comparing the of agent with those return, and then comparing the performance of both will give me an idea that how good or bad I am performing. But the emergent behavior, it will still not guarantee that it will do it in future. But you have to find that sweet spot, that when you are confident that this is enough sample size. Now I have tested this agent, and it has provided me enough evidence to actually give you confidence that you can deploy it on any real-time setting. But still there is some kind of human feedback or security mechanism which you have to implement in order to avoid different outcomes. Like in reinforcement learning, you have to define your action space. You can put constraints on your action space in order to avoid the consequences of any erratic actions from your agent. So you can define those constraints in order to make your agent more constrained and work in a very limited action space, instead of giving everything giving it everything and then using it for a real-time setting. So these are the two techniques which are basically used. First of all, get a baseline and compare the performance of your agent with baseline. The baseline could be a deterministic policy, or it could be based on some real-time data. So you can maybe deploy it on a test net or something like that and test that how both strategies are working. And another one is to add some constraints inside your model, which actually which can make exploration more constrained instead of giving.
Yeah, no, thanks for that answer. I think comparing what makes sense, because even before I got to reinforcement learning to train these agents, my initial plan was to make these or configure rule-based agents. So then define for each agent, what are their heuristics, what information do they act on, and then just codify these rules for them to observe the different state variables and then make an action that feeds into the policy function in the CAD framework. So I think that makes sense in using those kind of rules to validate the actions that arise from an agent that's been trained on reinforcement learning. When it comes to the
different reinforcement learning agents to compare their strategies. Sorry, I just interrupted you.
No. Okay, yeah, no, that also makes sense. And then I don't quite understand adding constraints into the exploration phase. So do you mean by kind of saying when it comes to the reinforcement learning stage, defining a rather closed constraint scope for action that the agent can take? I didn't quite understand that point.
So for specifically in reinforcement learning, let's say we try to explain with an example that you are building an agent for providing liquidity on Uniswap pool, and this agent gives you a range of upper tick and lower tick in which you provide your liquidity. So there is one option to let the RL agent choose from any range between the lowest tick and maximum tick which Uniswap pool has. The other one approach, which is basically the constrained action space, that you ask your agent to only give an action which is plus minus 100% of your current price. So you constrain that action space in that one plus minus 100% range. So if your current price is 5,000, so it will always give you an action which is between 0 and 10,000. So it will not exceed that limit. So the actions are constrained. If in the other case, if you have unlimited exploration space, then it can maybe ask you to provide liquidity in a range which is in 50,000 price range, which doesn't make any sense. So you train it to become constrained in that domain so that it learns to because if you are not using those constraints, it will take much longer time to get trained, because you have to provide enough samples to slash it, to give it a negative reward, to make it realize that this section is not suitable. So if you are training it for lesser steps, maybe 10,000 or 1 million type steps, then it can't really learn that behavior. So in order your algorithm to converge quickly, you constrain this action space so that it can learn quickly. So that's what I meant from constraining action space.
Okay, yeah, no, perfect. Yeah, understood. Thanks for that. And then, yeah, just one last question. Sorry, I don't want to take up all the time. But basically, kind of the purpose of, or at least how I've approached this modeling exercise and the outcome, or what I want to get out of it, is to, given the probabilistic nature of financial markets, and especially in the realm of Web3, the more volatile nature, I found it to be almost less valuable, or very difficult to almost get a pinpoint estimate of what the future could be, but rather I use the modeling exercise as rather to get an idea of what the range of possible outcomes could be. And I generally do that by running Monte Carlo simulations. And then I just wanted to get your opinion on whether you, or if you had any other thoughts or any other kind of different value adds that modeling and simulations can provide outside of getting that range of likely outcomes. Because yeah, for me, I struggled a lot with this kind of expectation from simulations to almost be the oracle or the holy grail, to be able to tell the future, which it can't necessarily do, especially if the assumptions that have been made are quite naive, and also it varies with the degree of, or the amount of confidence I have in the assumptions that I've used. So what would you say, if I can distill the question, what would you say is the biggest value add from a simulation or modeling exercise?
So it's pretty much what you said, that it's basically the purpose of modeling and simulation is to predict the possible outcomes which you can face in future. But I think the problem here is that we are facing with that dilemma of that how much complexity or how much accuracy we need to capture inside our model or simulation in order to make it achieve the business goals which we want to achieve. So the complexity versus simplicity, this trade-off between these two things, that's something which most of us really struggle. Sometimes the most simplest model for your use case can be the one that could be add most value in your product. So it's always predicting future. You are always trying to predict future, but you just have to ensure that the outcome adds some value towards your business goals, instead of achieving complexity to a level which doesn't contribute anything. So apart from the prediction of future, I actually employed these modeling and simulations to the design phase is all about it's not about predicting the future outcome. It's basically exploring the interaction between the agents. So interactions could be evolutionary, but sometimes they can be that much complex. Even in the present scenario, you cannot predict the outcome of simplest action. So you don't have to go and extrapolate over the time in order to feel that how complex these complex systems behave. But just to understand these mechanisms, you can use simulations which can be more productive, which I realize that they are more informative instead of making predictions and making doing things which will happen in future. You can understand more about your system in current state. So that's where I think it adds more value to the system, by aligning your models and simulations and using them to understand different kind of dynamics, and then adding that value to your business.
Cool, perfect. Thank you, Mohammed.
Thank you. Do we have any other question?
Several times, thank you. I think this was quite a helpful advice and sharing your perspective regarding the value of simulations. Let me check. I think there are no other questions at this point. Feel free again. We have some minutes left to switch on your mics or drop a note in the chat. I wonder, well, maybe we'll have some more messages. I wonder, Muhammad, if we go over the questions you have raised on Discord, like what are the most important challenges? Can you share some of your thoughts on, because of course, it's not by accident that you've raised these comments, right? Let me just pull them up again.
I had a slide here, I think, yeah.
Ah, you have even a slide. Okay, yeah.
Yeah. Okay,
So-
so these, yeah, please continue.
No, you can go.
Okay. So this was actually a trick question because all of these challenges are very real and and you answered it very rightly because you reacted on every emoji. I saw your response on Discord. So
Still, we
all
have
these
two
challenges
leaders,
are,
I must say. So people think that most of them think that the second mathematical definition of complexity and finding a trade-off between complexity and simplicity of models is most important. I mean, this is obviously not representative, but any thoughts why this is the favorite challenge?
for me, the first one was the most difficult because most of the time you were doing all this stuff, modeling and simulations, and when you present it to a stakeholder who is non-programming and don't have any background, so he can't understand that what is happening here. He can't play with it, and he really doesn't trust the system which you have built. So I think communicating with them is one of the part, but making these tools user friendly and making these tools more comprehensible to the non-programming stakeholders, that is the most important, because token engineering works very much hands in with the product development, or investors are the actual stakeholders who are part of the ecosystem. So if they can't really get the value from the stuff which you are doing, so it doesn't make any sense to do that. So that's the one of the challenge which I think which needs to be addressed, being a token engineering researcher, that you have to build that interface, build those frameworks, build those tools which can be more user friendly, which can be easy to build and easy to operate and easy to understand.
And I must say, with the DAOs now, having let's say stakeholders with multiple backgrounds, with we at this point, DAO decision makers, this is not a profession, so you never know how much they can invest in terms of understanding simulation insights and drawing conclusions and then taking a decision. This even adds more challenges in how to communicate and how to make insights based on simulations available to DAO decision makers, I think.
Exactly. So this is actually the core of this decentralization philosophy, that if you don't have that technical knowledge, so you can't really help the system, you can't really contribute in the system. So that's another kind of status quo which is being built by the people who have knowledge of a certain domain. So the core of this philosophy of decentralization is that power should always be democratized, and every individual who has the right to give its influence. So in that case, we have to give this access of different tools to users who aren't that much technical, so that this decision making in DAOs or even in any decentralized system, that can be more transparent if many people are contributing in it, and if they have enough tools to actually participate in these kind of activities.
Yeah, excited to explore Token GPT with you, I must say.
Yeah, that's very interesting. That's very interesting. I have built the first part of implementing retrieval augmented generation, and then I'm working on integrating different tools, subgraph APIs and Dual Analytics, Phylama, and all those APIs. And I'm working on that. So in demo, it will not be complete, but I will try to work on this weekend so that I can make it presentable.
And what are the use cases you are currently exploring with Token GPT?
So initially, I'm trying to make it as generic as I can, and then I can make it more specific to certain domains, like integrating liquidity provisioning framework with ChatGPT, so that in order to run ILP framework and run that tool and optimize parameters, you don't have to go and run those simulations, or maybe go and interact with the applications. So you can do it with a text interface. You can sweep parameters through a text-based interface. So that's where we will try to dive into the specializations, where we can have multiple GPTs, one for the liquidity provisioning, one for on-chain analytics, and that kind of stuff.
I see. Okay. And do you, so meaning the model part is covered by CAD models, or does it follow a particular framework or structure?
No, actually, these CAD models aren't part of it. I am currently more focused on the data side of things, that how to extract data and different tools to analyze that data, and then we can have make a infrastructure where any tool can be integrated within it. So if you have a tool which has it is a CAD model, so you can integrate it with the Token GPT without doing much of a sell. So you can provide a text-based interface to your tool with some simple actions you can do. So it will be more like a infrastructure where tools can be built, where people can contribute their tools. They can come up with different ideas and use cases and build on top of that.
Okay, cool.
Do we have any other questions?
As far as I can see, no. Last chance, everyone. Drop a question to the chat in case you have any. All questions are welcome. No stupid questions. And otherwise, we'll meet again next week. Same time, same place, Zoom link. And in the meantime, feel free to continue the conversation on our Discord channel and check out the study season information hub. I dropped the link to the chat again, where you can find all the links, all the timelines, also the material Muhammad shares with us, the links for every session. This is all captured and available at the study season information hub. Okay. Thanks, Muhammad, for this session today. Can't wait for the next round next week. And thanks everyone for joining the session today in Zoom or on Twitter or on YouTube. And see you next week.